Hello, hello. Can you hear me? Can you see me? I think yes, I'm getting information that everything is fine. Let's just wait a few more, like 1 more minute to start. Okay, so thanks for joining. I can see that we have around 20, more than 20 people already joining us. I know from experience that people are joining later on when the email reminder from the system is coming. So anyway, I think this is a good moment to start. So hi, my name is Adam. I'm a CEO and co-founder of Real Platform, a neuromarketing platform for also eye tracking research, but not only. So today, I would like to show you several things. I will start with the agenda. So first of all, I would like to welcome you and present the agenda. That's the thing that I'm doing right now. The next thing is I would like to speak a little bit about the online and the offline approach of gathering eye tracking data. What are the biggest differences, which option to choose, do's and don'ts, and so on. Then we have a little surprise, especially for the educational sector. So for the edu part of our audience, I know from the registrations that we had almost 50% of people joining from different universities and different research institutes from all around the world. So we have something for you. Then after that, we are going to do a live fielding. So I've created a study just a moment ago. The study is empty. There are just like a few results for testing purposes. And I will share with you the test, the participate, and afterwards, after you finish the participation, I would like to show you how I created this test by sharing my screen and creating the same test on our platform. Later on, we are going to do a little session for the data analysis. So I assume that since probably majority of you is joining from a laptop or PC and will be able to take a part in the study, we're going to have plenty of results to analyze. So I would like to tell you a bit about the data quality, how to check it, what to expect, about the metrics that our platform can provide, and obviously the conclusions. Afterwards, we're going to have a Q&A session. I hope we will be able to fit everything in 1 hour. That was the main idea, to make a 1 hour presentation, 1 hour webinar. But obviously, if you have more questions, then my time is not really limited this evening. So I can stay and talk with you and answer your questions whenever you will have more and more. Okay, with me there is Beata, who is going to answer your questions on the chat. Meanwhile, the presentation is going on. Also, Kasia and Damian from Polish team. I know that our Latin America team is also supporting us with the webinar, but later on about it during the presentation. So let's start. So let's imagine that you have to conduct an eye tracking study, eye tracking experiment with 20 different stimuli with additional questionnaires presented after the test on 100 participants. So here are your options. The first option, probably the most common and usual, was to do it offline. But there are some obstacles. First of all, you have to set up the entire laboratory, unless it's already set it up, so purchase expensive hardware, licenses, and so on. Then you have to collect the data, and because the fielding is offline, the participants have to go to the laboratory, sit down, have a coffee, chit chat, and so on. So the data collection is really slow. And because of this, you can only have local participants. You cannot test someone from US sitting in Europe. There are some advantages, obviously. So you're going to get a pretty high accuracy. We like to call it a letter size accuracy. And you can expect up to 240 hertz or even more, depends on the hardware you're going to use. But the biggest pain in this process is that you have to wait at least 2 weeks, in this case, for the data And you, as a scientist, as a researchers, we really like to play with the data, not wait for the data. So why 2 weeks? I assume that 100 participants divided by, I don't know, 10 per day and so on. It gives us around 10 working days or even more actually. So at Relay, we decided to do things a bit differently. So we have changed already existing devices. These are webcams into data collectors. So thanks to this, the panelists can stay 100% online. You don't have to limit yourself to only offline panelists staying at your city in your country, and you're going to get the result immediately after every participant finishes the test. The entire cost of the setup is way lower than the hardware, obviously, because there's no need to purchase a specific hardware for this purpose. There are a few disadvantages. You're going to get a lower accuracy. We like to call it a button size accuracy, but for some types of studies, this is perfectly fine. Plus, you can overlap the accuracy gap, hiring a bit more participants. And also, you're going to get up to 60 hertz, but usually around 30 hertz frame rate, because webcams are operating on the 30 frames per second frequency. So the biggest win here is that you're going to get the results today or maybe tomorrow. So this is a huge win for doing research online. So a few more words about what we are providing at Relay. We obviously are providing webcam eye tracking to follow participants' gazes. We also provide a facial coding tool to detect participants' emotions while they're watching, for instance, a video advertisement. We also have kind of like a module for reaction time tests. So you can study how fast people were reacting by clicking or pressing a keyboard. Also, we've recently implemented for one of our partners a survey module, advanced survey module. We call it Awesome Survey Module to provide the ability to ask declarative questions to the audience, which is really helpful if you want to ask people not only about their kind of like see what's the difference between their behavioral reactions versus their declarative answers, because very often these are two different things. Other than this, we provide an analysis dashboard with the ability to export all the data to CSV, which I know that universities really love, and it's all under a single license. Relay allowed us to run research projects with the friction of the price of a typical eye tracking software hardware, says Giovanni Federico, a psychologist from Italy. But not only Giovanni trusted us, more than 1,000 companies from all over the world trusted us, including 50 universities. So you can kind of like be sure that this our solution is pretty legit, but also we are aware that it requires you to kind of like take the leap of faith before trying new tools, before trying new solutions. It's very similar whenever you are, I don't know, like changing your phone from, I don't know, Android to iPhone or otherwise, then you have to kind of like take a leap of faith and try to believe that the new thing is going to be better. It's going to solve your problems. So as by saying this, I mean that we're here to help you understand how webcam eye tracking works and what are the biggest advantages and disadvantages. You can always reach us out through this chat bubble on our website. There, usually you're going to find some of our team, myself, Damian, Naut, Beata, Tanya, Pablo, Christian, Sebastian, Kasia, or Sylvia will be really happy to help you out, guys. So you don't have to be afraid about webcam eye tracking or moving your research online. Okay, I think this is a time for the surprise, for the educational part. So we're getting some emails from very different universities from all over the world that very often they might not have the budget for our tools, or the budgets are already closed for this year. But on the other hand, we would really like to enable these universities to work with our tool to provide the researchers. So we decided to run kind of like a I don't know how to say, like an event. We call it kind of like a coffee break talks, where we would like to grant universities or researchers who would like to share with us their story, their research story, their conclusions in a way of a like 10, 15-minute interview. And thanks, if we decide to use the material and publish it in as a video containing this research, as an 10-15 minutes interview, we'll be really happy to provide a license, a 4-month license for the universities or academics who would like to share their story with us. So if you would like to be part of it, we're going to obviously publish it on social media. But if you'd like to be part of it, please send an email to Kasia at Relay.io. Kasia is going to be responsible for this project from our end. Okay, so let me check how many participants we have right now, and we are going to do a live fielding session because I believe that this is why you came to this webinar, to see how the data fielding and how the data analysis is being done live. So we are going to, I'm going to share with you here right now on the chat a link to one of the studies that I've created a minute ago. So please go ahead. If you are using a desktop or a laptop device with a webcam, you'll be able to join the test and bring the results for our eye tracking part. So I'll just mute myself for the next 5 minutes. I will also do the test by myself. So for those who don't have the webcams or laptops can see how it works and looks, but I'm going to mute myself. See you in 5 minutes. Please participate. Please, please, please. More data means more conclusions. Okay, let's check how many results we already have gathered. Okay, right now we have 12 results, so let's just wait a bit more. Maybe we're going to get a few more results. Let me show you how it looks when I'm checking the amount of results. You should be able to see my screen right now. Yep, there it is. So here, this is the study dashboard, and we can see live that the results are appearing. So right now we have 16 results. Let's just wait a bit more until the counter will be kind of like static. As you can see, results are still on their way. 18 results. Still 18. A few more seconds. Okay, so for those who are still doing the study, then please feel free to finish. And in the meantime, I'm going to just prepare the rest of the presentation. So we are here. We are at the live fielding. And according to the presentation, we are right now going to show you how to create a study like this. So we have 20 results. Great. Actually, I was hoping to get to 20. So let me then go to the dashboard and create a new study. So that was an images-based study. You can also do studies based on videos or a live website. This is pretty specific. You can test it out by yourself. So let's go and create an images-based study. Few options at the beginning. So let's call it webinar study. Show items in random order. That is okay. So separator between items, that was actually disabled. Ask my participants about name, gender, and age. That was enabled. That was the end, the pop-up at the end asking for the name, gender, and age. I'll show later on why I needed it. Enabled external tool integration was disabled. There was no need in case we would do the fielding with some external panel, like, I don't know, Qualtrics or Prolific. Actually, Qualtrics is more than a serving panel, but basically, if you'd like to use some external server panel, this is the place to go. Optional intro message, optional message after the test. These were empty. Second step was uploading images, uploading the items, which were the part of the study. So let's go here. As you may remember or not, the study was the study began with the planogram. Then we had the two versions of the advertisement. These were actually randomly presented. I'm going to show you how to achieve it. Afterwards, we had, I believe, a real life website. Then we were testing this pop-up on our website. And then at the end, we had this tool. Just give me a second. Okay, I just got notified that I'm showing a presentation instead of the screen. Should be okay right now. Sorry, let me just go back and show you a bit the study setup page. It was actually not really complicated, but let me go to here, to this step one. Okay, so I've created a new study that was an images-based study. I gave it a name, webinar study. I checked show items in random order and asked my participants about name, gender, and age. Separator between items was disabled. And I left the optional messages just like this. So step number 2 is to upload the items. So as I was saying, the first one was a planogram. Then we had 2 different versions of the same advertisement. Then we had a website, a pop-up on the website, and this little internet beam close, which looks a bit like this, the motivator or something like this. So let's wait for them to be uploaded. I'll just double check if my screen is being shared instead of my presentation right now. Hopefully yes. Yeah, okay, just got information that everything is fine. So going back to sharing the screen, and images are uploaded right now. So let's move around and reorder them. So planogram was the first one, then 2 advertisements, then there was the website, pop-up, Actually, I should upload the website stimuli once again because it was displayed just for a moment. And then you could see the pop-up on it. So I was actually using a pretty cool methodology invented by our partners in Latin America to measure how people are reacting to these pop-ups, how much time they need to click to kind of like disable it. So we can A/B test pop-ups and see how attractive they are until people click X while they are disturbing your normal flow. Okay, so that's this more or less the study flow. What I wanted to right now underline that this one, I'm going to pin the items so they will be disparate in desired order. So even though in the study setup, I selected that it's random, I'll pin this one because I want this one to be presented as the first one. Then I'm not going to pin these two. I want them to be presented in random order. And then I'm going to pin the rest of the items. There's also an IKEA catalog. Sorry, forgot about that. I believe that was these two images. So these were presented right after the website, and they were also pinned. Okay. So here we have several options for each of the items. Before presenting this one, I asked, please click the product you'd purchase. And I've set it a 20 seconds display limit. The finish on click was turned on. So this option allows you to map some section of an image which is active, which is clickable. In this case, I've simply activated the entire screen. Okay, then the second stimuli was displayed for 5 seconds. The third one was also 5 seconds. By the way, after the first one, there was the question, and that was a choice question asking you, have you found the you usually purchase or something like this, and that was a choice question. So there is an option to decide either it's a text answer, choice, 1 to 5 rating scale, matrix, or images as answers. This one was choice, and the choice was pretty simple. Either it was yes or no. Minimum one choice is required. It means that this question is required. So moving on. This one will be displayed for 5 seconds, 5 seconds. Then we have the website, and I've displayed that. I've set it that this has to be displayed for 2 seconds, and there was a line of instruction. Please click the pricing button. Display time was set to 2 seconds, scrolling was on, and nothing else. Then after 2 seconds, this item was displayed, and I allowed you, the participants, to browse this page for 20 seconds, and everything was perfectly fine. And also, the finish on click was mapped to this image. So after you click this image, then it automatically went to another image, which was again the screenshot of the website. Here, I allowed 20 seconds free browsing, and I turned on the finish on click, and it was mapped on the pricing button. That was the flow I arranged. Okay, now here was the IKEA catalog, and the instruction was, please take a look at the IKEA catalog, press spacebar to move to the next page. So in this case, I turned on the finish on key press element, which allows participants to move to the next item whenever the key is pressed. Also, these two were pinned. And again, turn on the key press, and the maximum display time was 20 seconds. Then there was the survey, which was presented after the second IKEA catalog, and it was asking you, the question was, please choose the products you would purchase to your home or something like this. And here we use the images as answers type of the answer. So it allows you to add multiple images and provide them as a choice or multiple choice answer. So that's it. You can also rearrange the answers as you wish. But anyway, I will randomize the answers and set that minimum 0 choices are required and the maximum 8 because there are 8 images here. Okay, and then there was the matrix type of a question with columns saying don't agree, neutral, and agree, and the rows asking us what do you feel about IKEA? About what do you think about IKEA? Let's say in the matter of design, quality, shipping, and there was the third one. I don't really remember. The first one was about the quality in general, and the third was about the design. So this is how you can set up a matrix type of a question. We can also randomize the answers, but not the columns. So this is how it's going to look. I'm going to save it, and after the last stim, there was also a one question which was really fast and straightforward. 1 to 5 scale, how much you enjoyed this demo. So that's the test. This is the entire setup for the eye tracking study that you just participated in. If I would like to run it live, then I have two options to do the preview, either the quick preview or the full preview. If I would like to run it, I have to choose the amount of participants. Let's say I would like to invite 20 people to the study. I would just have to click the run study button. And this is the link that I shared with you during the just before the fielding begin. Okay, let me go back to the study that was shared with you, so I can see that we have 23 results. Let's take a look at the results from the perspective of, first of all, the data quality, then metrics, and then the conclusions. So let's go and dive into the data quality section. For every participant, we have the ability to see the data quality grade from the scale from 1 to 6, when the 6 means 6 means perfect, and 1 means bad. So we can go and see participant by participant how the data quality looks like. Feels like we have a really nice results. We have a very low result right over here. Good, very good. But we can also see how the statistics are distributed over all the participants at once. So we can see that the average eye tracking data grade is good for the study, which is really great. And here we can also see the offset, which is something that our customers are asking pretty frequently. So the offset means that we can see the funnel of the statistics. So the test link was opened by 32 participants. 25 participants granted the webcam access. 25 participants had face detected. 24 has calibrated properly. So one of you, the calibration didn't work out properly due to some unknown reasons. And 23 have completed the test and provided the results. So we have the offset within around 72%. But the first step, so the 32 to 25, is something we can actually if we hire a panel and we told the participants that they need a webcam and they will need to give us access to the webcam, then this will become our 100%, because we're not going to face this step, this offset. I'm not sure if you know what I mean, but basically that's something you can work while hiring the panel. Okay, so let's go and see some results. So we have Carmen, Pablo. Let's go to Pablo's results. We can see that the data quality is very good. In case we don't like the results, we can ignore them. So if we feel that the very low data quality is not good for us. We can ignore the participant and bring him or her back at any time. Then the results are not going to be included into the data analysis. Okay, let's see the recording. This is the first type of the data Real Eye is providing. So this is the gaze recording, gaze representation in time. We have few options here, so we can show gaze plot, fixation plot, gaze point, and the mouse cursor. So what are these? So the gaze plot, this is not the best image to show. Yeah. So the gaze plot is the orange line, and it represents all the data that our eye tracker captured. So you can think of it. I'm just going to maneuver a noise reduction settings to show you. So these are all the dots that our eye tracker gathered. Thanks to based on the gaze plot, we can actually paint the fixation plot, because fixation plot represents all the fixation that our fixation algorithm was able to detect based on the cloud of the gaze point data. So you can see that these dots, these little yellow dots, are actually fixations. And the orange dot, it's pretty self-explanatory. It's basically the gaze point in life. So this is the first type of the data analysis. This is mostly for the qualitative type of research. So when you're asking participants to do something, for instance, on a live website, and then you would like to follow the path one by one to do the analysis. By the way, here's also the facial analysis toolbox. You can see that right now it's flat. This is pretty common situation for the images-based study. We wouldn't rather recommend running a facial coding analysis for the images-based study. The facial coding tool works pretty nice for the video-based studies, especially if the videos are meant to provide some emotions like happiness or surprise. Then it gives us a pretty cool types of information. Actually, I think we're going to set up a similar webinar, similar event for just showing you how to do the video-based analysis on our platform, but not today. Okay, so that's the first type of the data analysis. Then let's actually, before going to heat maps, let's see the answers from the surveys. So let's see how people were reacting to the question. Have you found your favorite product? Okay, pretty pretty nice results, because almost half of you have found the product that you really that you would purchase, that you like. We also have the survey was turned on here, so how easy was to find the pricing. So majority of you graded that it was easy, but that's pretty surprising. Probably we'll have to change a bit with our user interface so the pricing will be more visible or more clear. Here we have the analysis of the key press, and actually it will be great to also see the time after you were finishing showing this item, but that in a second. So you were pressing a key after an average 7,694 milliseconds. So that was how long you were browsing the first page of the catalog. The second page of the catalog was in average was displayed for 5 seconds, so it was probably a bit more boring. Then we can go to survey and see how the answers for the images type of question look like, and also for the matrix choice. So for instance, you as our audience think that IKEA is rather good quality. They have probably neutral shipping. You can see that it's almost in the middle, and they are rather have a great design. Good. Let's see the last question. How much you enjoyed this demo? And this is really nice to see that majority of you have enjoyed this demo. So thank you very much, because I've created it around half an hour ago. Okay, one thing, let's see how the pop-up thing worked. So let's go to heat maps, because we can see the average display time in the heat maps panel. But before jumping into these heat maps, let's open heat maps for the planogram just to see how it looks. So from the heat maps based on 23 panelists, which we can filter out, by the way, in case you would like to just see the results from female with some data quality filters and so on. We can see that you were pointing your view here for this red cans. We can use the arrow of interest tool to see the eye tracking metrics. So here we at Relay, we're trying to bring the metrics as close and as near as usual as for the typical eye tracking research. So we operate on two different verticals, either gazes or fixations. So the differences, just as I mentioned before, the gazes are all the dots that our eye tracker captured, and the fixations is the outcome of gathering the gazes into groups by denoising, firstly by denoising the gazes and then gathering them into groups. And then based on two rules, our algorithm is saying that this group of gazes is a fixation or not. And the first rule is that the sight had to be for at least a certain amount of time in this area. And the second rule is that the eye couldn't, that the eyes were not leaving this area uh, with the velocity that was set as a threshold. So this filter is called velocity threshold filter. So to set up the filter, we require these two parameters. What's the velocity threshold and what's the minimum time we, as a researchers, decide that the fixation is. So by default, these filters in our platform are here we can see the advanced settings. So minimal fixation duration is set to 100 milliseconds, and the gaze velocity threshold is set to 180% of the image per second. These two are can be easily configurable. As you can see, if I change these filters, I'm gonna get a bit different heat map, but basically it won't change that much. But for you researchers, if it matters, then you can freely maneuver these elements. Okay, so let's go back to the metrics. Let's just select the orange cans. I think these two are the same. So we can see that the average time to first fixation was around 3.3 seconds. The average time spent was around 0.63 seconds, and there were in total 31 fixations. Ratio, so how many of you have actually noticed this element, is 59%. Average fixation duration within this area was 0.27. Average first fixation duration, for some researchers, this is also a pretty good value to do the research, is 0.25. Average time, amount of revisit and clicks. So since the query was to click the product that you would like, we can also see which product got the most clicks, which are of interest. So let's say that this is the Evian water. We can save this are of interest. And then we can select the another product, which was, let's say, our A/B test. So let's say that it was the Perrier water. I'm not familiar with this brand. I have it here in Poland. Okay. So thanks to this, we can, for instance, do the analysis here. So that there were 2 clicks here and Avian got 4 clicks, or we can actually download the results of the areas of interest and do the analysis in the Excel. But let's face it, these are not very heavy analysis at this moment with such a few testers and just 2 areas of interest. Obviously, if you have more areas of interest, more participants, and you're doing these types of tests on scale, then using the CSV files or our API endpoints to get the data programmatically, it's pretty good thing to have. This is the heat maps built on gazes. You may ask why the fixations are kind of like this dots. It doesn't really matter. This is just a matter of the fine-tuning the image. You can fine-tune it as you wish to simply add the density of the heat map to get the nice views, nice kind of like nice images. But obviously the numbers behind it are not changing. It's just a matter of the density. We can also see the mouse movements and the mouse clicks that was already set. Okay, so what was actually interested is how much time you needed to kind of like disable this pop-up. So how to check it? We can see on the heat maps dashboard that majority of you were looking at the heat map at the pop-up. We can obviously do the analysis and see how many of you actually have noticed the re/event logo, how many of you have noticed the Kasia's name and surname and the email, and we can see that probably most of you, 23, most of you clicked the X button. Here, this little bubble shows us that you needed around 6.2 seconds to stop displaying this this image. So it means that after an average 6.2 seconds, you were clicking and killing the pop-up, which brought us to the next item, which was the proper website, which was being displayed for 20 seconds. And this is the heat map of the websites. Not many of you have scrolled down, but there are some fixations visible. We can also see how it looks on cases. So you're looking for pricing somewhere here. And actually that was pretty good idea because the pricing was here. And majority of you actually clicked pricing. Some of you clicked save your spot or start study. Okay, so this is, I believe this is eye tracking lesson 101. So how to create and field and very briefly analyze eye tracking data online. I think that this is a good moment for me to stop the presentation of the live demo and back to the slides, because I have a few slides showing you what are other use cases for utilizing our tool. So as mentioned, we are obviously webcam eye tracking provider, service, mouse clicking, mouse movements, and facial coding. And thanks to this, we can kind of like divide several different type of usages for the product. And our customers are showing us that actually these are pretty well divided groups. So first of all, you can see how your product is performing. You can decide, you can kind of like make a research about the visibility of the products, about purchase decisions, purchase intention, maybe biases, doing some implicit reaction time tests, just like the heat map I showed you previously. You can also do a similar research about brand performance, because you can also do some implicit tests, implicit reaction time tests to see, are people recognizing your brand, how fast people are recognizing your brand, what are their first top of mind kind of like reactions to the brand when it comes to different emotions. There's this methodology called implicit association testing. You can also do the methodology, utilize this methodology using our tool by using the key press feature. Moreover, Relay can be used for user experience testing and also advertising effectiveness, but also pretty often it's being used for academic research. And this is something that we really that we're also kind of like really happy about, because from academics we're taking a lot of knowledge and inspiration on what our tool should also provide, and at which areas our tool should be better at. Okay, that's it from my side. I believe this is a good moment for the Q&A session. Let me just enable it here. I have this option to show the most interesting questions and answers and answer them on the go. So the first question, it's about the research offer, about the offer for granting a free Relay license in return for the interview about the research. So yes, you should send your research proposals to Kasia. We're going to provide more communication about it. So please, if you already have some idea about it, please get in touch with Kasia, and we're going to choose kind of like few of them to the first series of these interviews, and the ones which are going to be published are going to get the license. Would the accuracy of eye tracking be less if there is no mouse movement? Does eye tracking be less if there's no mouse movement? Not sure how to answer this question. Basically, we're using our kind of like mouse cursor to do the calibration, because we need to kind of like the participants need to confirm the place where they're looking at by moving their mouse at the selected point, kind of like confirming that they're looking at this place. And then the algorithm, the system is learning that that you are looking at this place. Sorry, I have a support from Beata. Okay. I think the question was about if we can enable or disable the mouse movement. Basically, it's not. It's always on. Kind of like the mouse movements and facial coding and eye tracking. They're kind of like in one module. So the system is always tracking these three elements. By the way, it's worth sharing that Relay as a tool is never recording anything from your webcams. You don't have to be afraid about it at any kind of like never worry about it, because all the calculations are being made in your web browser, and everything what goes to Relay platform is just a set of the coordinates, sets of the data x, y, z, time, mouse cursor x, mouse cursor z, and some other statistics. We have one more question here. Is there any peer-reviewed study on the validity of using your solution or any webcam-based tracking solution? If I use this in my research, I would like to be able to justify the use of your tool during thesis defense. This is a good question, and actually we are getting this more and more over. There were already several publications using our webcam eye tracking, so we can always base your research, kind of like defend your research by saying that there were other research papers provided by it. But right now, we're also working on our research paper together with Kasia, who joined us recently. So we'll be able to provide such a paper, so you as a student can defend your thesis easier when there's a need for it. A little support from Beata here. Actually, we have a pretty nice article in our support section listing all the publications and all the mentions where Relay were already used, so that might be helpful in this case. I'm wondering if the accuracy would be less when watching a video. Thanks. No, that's basically the same. It's not. It doesn't change much. Does the quality of the webcam matter? That's a good question, because it does when the webcam is something above the average. So in case you invested and you have a webcam gathering the data in 60 frames per second, then you can expect that your data will be within 16 hertz. But other than this, it doesn't really matter if you have a webcam built into the laptop or a webcam which is kind of like external webcam plugged into the USB port. What would rather matter is the CPU and the browser that the participants are using. There's a lot of data, a lot of calculations to be done live while the participants are doing the eye tracking sessions. So that would probably, if I would have to kind of like wage these two, then the webcam quality is not that important as the entire laptop quality, which kind of like, if it's an average type of a laptop, it will be fine. Thanks, Alberto. What about emotional face reactions? Since the version, I believe 6.0, in Relay, we decided to provide the facial coding tool. And based on the facial coding, based on the methodology called FACS, invented by Paul Ekman, we're following the facial landmarks of the participants. We're doing it at the individual level. So while the participants are doing the calibration, the eye tracking calibration, we're also kind of like calibrating their default face. So if someone seems pretty sad by default, then this is his or hers 0.0. It's not going to show that the person was not happy all the time and so on. So based on the individual level, we are trying to provide the happiness and the surprise and the neutral level of the face. As mentioned, this module is enabled by default if you are on the university or standard or above license. Okay, next one. What eye tracking technologies are using? Is it developed by you? Sorry, a little support. Okay, that's a good question and a good idea from Damian. So we are basically using a browser-based technologies written in JavaScript. We are using several open source projects. We're using to face mesh. We're using the WebGazer library. We're using also Pico.js library. Some of it is developed by us in-house. Some of them is optimized by us in-house. Some of them is open source. So we're kind of like combining several different tools, libraries, and taking the best out of them. We're also doing a lot of job when it comes to the data analysis afterwards and the data denoising and the fixation filtering and so on, which is happening on the backend. So I would say that the tech stack we're using is something in between the front end and the backend. So JavaScript plus data processing. Mouse movement I asked about is after calibration. Not sure if I understand the question. I would appreciate if you could paraphrase the question, and I'm just going to move to the next one. I'm sure Beata is going to put the question in the line. What do you mean by button size, literal? Yeah, moreover, so the accuracy of our webcam eye tracking tool is around 110 pixels. So this is kind of like the size of a typical button on the website. Meanwhile, if you're using eye tracker like Tobii, GP3 or something, you could probably expect a lower area of interest, kind of like the better accuracy. We like to say it's kind of like a letter size accuracy, but obviously the accuracy depends on many different factors. This is what I'm saying is kind of like the average. Initial instructions may be in other languages. Yes, we right now provide the entire test can be handled in different languages. Actually, it's very easy for us to add additional translations just to the test flow. So right now we support, I think, around 9 or 10 languages. In case your language is not on the list or the translations are missing or are not actual, then you can simply let us know, and together we can update the translations so they are kind of like updated and at the best stage. Is there a recommended browser for video experiments? Firefox, Safari, Chrome? Yes, we definitely recommend Chrome-based browsers. Chrome, I mean Chromium. This is the engine of Chrome web browser. So obviously Chrome is one of the browsers which is using it, but also Microsoft Edge, since I believe mid 2020 is using Chromium engine. So Edge browser, Microsoft Edge browser is perfect for our tests. We also work on on Firefox. I'm not that sure about Safari. Some time ago, we had some troubles and we decided not to support it. And we're displaying kind of like the pop-up in the middle that, sorry, please use different web browser to continue the test. So that's something that probably you should add to the fielding questions if you're using an external panel. Hello, I know mobile tablet support is not available as for yet. However, is really looking to implement this tech while keeping the great accuracy? If so, could you estimate a year, quarter? Thank you. We're kind of like we keep our hands on the how close we are to develop the real eye for mobile devices. Right now, we still think it might be hard to do it at scale. So let me explain what I mean. Like one of the biggest advantages of real eye is that people from all over the world can participate in eye tracking tests without installing any additional software, and they can use just their regular web browser on their regular laptop, and the data quality seems to be really good. So by when we enable the mobile eye tracking, we need to make sure that we will have the same kind of like values, the same value proposition. So we can't ask our participants to install anything on their mobile devices, because that would simply like kill the ability to scale the studies. And at the same time, we would like to keep the same type of accuracy. Right now, from our point of view, it seems that we would have, since the Safari is the default web browser for iPhone, which is often opened as the default, we would have issues with working on iPhones. So we could probably develop just the Real Eye tool just for Android users, and I'm still not sure if we would be able to keep the same accuracy at the same level. So we're still not there yet. In case some other webcam eye tracking provider offers you mobile eye tracking, then that's really great. Please double, triple check that your fielding will go fine and you won't have to kind of like cut off half of your audience, and that the accuracy is good. From our perspective, it seems that we are rather not there yet. but we will probably sooner than later. Okay, two more. Hello, does it create a problem if the participants wear eyeglasses? If there's no reflections on the glasses, then it's not an issue for the webcam eye trackers at all. Actually, our technical founder Damian is wearing glasses and was doing the tests from the very beginning in his glasses, and he was not complaining. Maybe he actually was trying to fit it to his face and the glasses. That's why it works on the glasses, because he was testing it this way. And the first image, how do you ask for the purchase intention? At the first image, how do you ask for the purchase? So what I did was I used, okay, again, this way, I used the ability to set the instruction before displaying the item. So that was how it was done. So whenever I was on the study setup, then I could edit this piece of text to achieve what I wanted. Damien asked me actually to show us maybe if there was any emotional reaction for the last image. Let's see. Okay, so you can see that the emotional detector actually got you surprised with the stimuli, and also when you were halfway through, it detected smile on your faces. So yeah, that was a bit of the intention for it. Okay, let me see if there are any more questions. If there are no more questions, then I would simply leave this webinar right now. I will leave you with the information that please follow our social networks. There is a lot of things happening in the eye tracking, in the webcam eye tracking world. We're trying to provide the information on the go. Also, we're going to promote several events just like this one on our social media. So I think this is the best way to be simply in touch with all the news from the neuromarketing and from the eye tracking, webcam eye tracking perspective. Okay, thank you very much for staying with me here. Thanks team for helping me out with the questions and supporting me. So thank you. I will just present the last slide in case you would like to reach me out by email. Have a good day. Bye bye.